Um, oh, spoilers! We've seen the last algorithm already. Um, so, an algorithm, it sounds fancy, and everyone's sort of scared of it initially. But you've already written tons of algorithms. Every function that you write is technically an algorithm. It's just a process or a set of rules to follow. That is all it is. Um, it's quite often mathematical problems, mathematical functions, but really, I mean, these days we're kind of used to referring to like the YouTube algorithm or the Google algorithm, and really it's just one function, one process that receives, in the YouTube algorithms example, receives maybe a user ID, and it runs that user ID and that user's watch history through a bunch of rules, and it, at the end of it, it returns like an array of videos that are recommended for that user. So really, it can get incredibly complicated, but actually it's just a function that follows a process. It's really good practice for just programming the way that you should approach writing functions and problem solving, just kind of logical thinking. The reality is, you don't. It's unlikely that you'll be writing a sort of YouTube recommendation algorithm, because the types of people that tend to work on those sorts of products and those sorts of algorithms are, I mean, I guess sort of data scientists, but really probably kind of maths graduates and real scientists, to do the really super complicated stuff. But like I said, every function is technically an algorithm, and it's really good to learn how to write tests, because we're being told, okay, we must write some code, we must write a function that follows this set of rules. Therefore, if based on this input we expect to get this output, and that's a really nice and testable function. So the first one we're going to look at is we want to find the maximum difference given an array of numbers. So between any two elements in our array, we're going to get an array of numbers. Between any two elements, we want to return what the maximum possible difference is going to be. Here is an example. We have an array of 0, 5, and 10. And the result in this case is going to be 10. The biggest difference in this array, we have 0 and 5. The difference is 5. We have 0 and 10. The difference is 10. And we have 5 and 10, where the difference is 5. So the largest difference in that set of combinations of numbers is between 0 and 10. Therefore, the result in this case is going to be 10. This is how you're going to write it. I'll paste this into the Slack channel, but you're going to start with a test array. Here's one I made earlier. We have a function called maxDiff that receives the array and returns a result. Yep, this doesn't do anything. It will just, in fact, cause an error because result is undefined. But we have a function called maxDiff, takes an array and returns a value that represents the maximum difference in that array of numbers. We then, in this case, we're just going to log out the result of calling maxDiff with that test array. So we're going to have 15 minutes on the clock for this first one, because you'll kind of faff around setting stuff up. So start faffing around setting stuff up, I'm going to send this in the Slack channel. So you want to copy that in some sort of folder. I'm putting all of this in the lesson folder, so it is going to be available to you after the lesson when I've uploaded it. I'm going to have one file called maxdiff. We're going to have all of these in separate files. It just makes it nice and neat. So we're going to have, then we paste that code into the maxdiff file, and as ever we run node or nodemon, and we run maxdiff. So as expected, we get an error. I'm going to set 15 minutes on the clock, 15-minute timer. Done. We're off. So I'm going to do it as well. So please do feel free to, well, no, you kind of a requirement, I guess. Please do give it a go. But if after sort of 10 minutes or so, it's kind of you're stuck and you can't figure out how to do it, I'll hopefully we're finished by then, and you can kind of refer to what I've been doing. But so you can kind of concentrate, I'll shut up now for the next 15 minutes or so. Good luck. If you want to ask any questions along the way, then post them in the video chat, and I'll do my best to help you if I can. Dahe just made a good point, actually. If you have done it, and if we get to the point where everyone's done it, then we can finish the time early. So write in the chat if you have completed it. Oh, don't post the code. Others can cheat. No, it's fine. You can post the code. It's fine. Don't worry. There's 3 minutes left. One minute, and if you've done it, then try to do it in a different way. I've done it in 3 different ways. I'm sure there are plenty more, but I can think of 3 different ways to do it. Ten seconds, and let's call it there. Actually, let's hear what the noise sounds like. That's not a very nice noise. Okay, right, so Dahe posted that they've done it. Who else has finished it, or who else got close, or who else or who kind of didn't manage to do it and has some specific things that tripped them up? How did everyone do? It went that well, huh? Or is something broken? Can anyone say something? Well, okay, Daniel, would the highest number be difference as well? I'm just going to wait. Yeah, okay, that's fair enough. I mean, I can't hear anything and nothing's moving on the screen, so maybe people are talking and I just can't hear them, but let's face it, that's probably unlikely. So, I've done it 3 different ways. One of them is pretty similar to the way that Dahe posted. Mushtaq says, would the highest number be difference as well? I'm not entirely sure what that question means, but certainly that's one way to approach it, finding out the highest number and the lowest number, and there's a couple of different ways to do that. So the first way that I did it is, to me, probably how it's almost the kind of simplest in a way. It's actually probably the most complicated, but it's or at least sort of a few years ago, it would have been the way that I thought about achieving it first. And you have your array, you create a variable using let, because we're going to change it, that is storing the current highest difference. We then iterate over every number in the array, and then for each of those numbers in the array, we iterate again over each number in the array. And I'll come back to this. And then here, if the difference between the current number that we're looking at in this array and the other number that we're looking at in this array is greater than the current highest difference that we're storing, then let's set the highest difference that we're storing to be that new difference. And then after that double iteration has occurred, we can return highest diff. So that is it's a perfectly valid way to do it. It's reasonably readable. I think having a kind of nested iteration is pretty. Sometimes it's unavoidable, but it's in this case, it's something you generally want to avoid, because we don't need to do that. Here, for every number, so that's 1, 2, 3, 4, 5, 6, we're iterating over every number. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So that's 6 times 6, 36, I think. And then you add one more number to the array, and it suddenly becomes 49, I think. And it increases kind of not exponentially, but it increases. I don't know, by the square of the total length of the array. So having this nested iteration isn't great. What I've done here is just a very, very small optimization. If we're worried about optimizing this algorithm, this is not the approach that we want to take. But if what happened here, if that was actually a relatively complex piece of computation, we would want to avoid doing that if we don't have to. So here we have the index in this array, and we also have the index of the same array but the other number in the same array. And if I is equal to j, if we're currently comparing number 0 and number 0, so 5 and 5, we don't want to compare those. So we check that we're comparing the same number to itself, in which case just return from this function, just don't run this code. It's pretty unnecessary. If we were worried about optimization, this is not really the best way to do it. But you do want to start thinking about small things like that, especially if you're doing much more complicated stuff than this. So we can see max diff here, we get 24. That was the correct answer with our original test array. I then chucked in another one, 100, 0, 5, 10, and we get 100 back from that one. Next, I did it slightly differently, actually very differently. The math global object has two functions in it, one called max and one called min. They take any number of arguments. So what we want to do is pass these numbers, through to max as separate arguments, like this. And that's where we can use the spread operator. I can't quite remember if I've already done the kind of ES6 lesson, or maybe that's this Thursday. I imagine it probably is this Thursday. I think we've talked about the spread operator a little bit. Essentially, that's taking all of the elements inside the array and pretty much just deleting the square brackets. It's just spreading them out so that they can be passed through as separate arguments. So this function takes a whole load of numbers and it returns the highest number that has been passed to it. Math.min obviously does the opposite. It returns the lowest number that was passed to it, and then we return the absolute value after subtracting the lowest value from the highest value. Now, if we have our highest value is max, so in fact let's do negative 100. Let's see what we get. Negative 100 and 100. So that is the biggest difference. The biggest difference hasn't actually changed. But if we don't take that max minus min, so what is max in that case? Is max going to be 10 and min going to be minus 5? I mean minus 100. I don't know actually. That's interesting. So let's see max min. My computer's really not enjoying this. Okay, so here we've now got 10 as the max and minus 100 as the min. So actually that still works out saying max minus min, but I basically, the absolute value, I kind of always pass stuff through to the absolute value. It sort of just saves me thinking about it. I know I want a positive integer in this case, and that's what the absolute value does. Returns the absolute value of a number. The absolute value of minus 5 is 5. It's always the positive version of the number that you're using. And I think because I just always want the positive number, I just, so I don't have to think about it, I always pass it through to math.abs. Now, the third way that I did it, this I think was the same way that Dahe did it. It's pretty much going down the same route as this. It's just using sort instead of max and min. So first, I make a copy of the array. So here I've used the spread operator, but you could have used slice. So sort mutates the original array. So what we would not want to do here is call sort on the array that gets passed through directly, which I think is what Dahe has. So, yeah, in fact, there's another issue with this one. So, sorted is actually going to give you. Actually, is it? I assume it does. Sort gives you the array back, but actually, you don't really need to store that because your test array has actually been sorted. So here, this function that Dahe's written is receiving an array argument, and in fact, it's ignoring that array argument. So where I now have two examples, this wouldn't work on this second example because we're passing the array through and then it's just going outside of the function scope to access this global variable test array. So you always want to refer to arguments that are being passed through to your functions. So that's a slight improvement. We're now sorting the array that comes through to the function. Now this would work as well as this one. But if we call maxdiff there and then we call some other function on the test array and we call some other function on it, as soon as we call array.sort, we're actually changing our original test array, which is why in my version I am creating a copy of the array that I then sort and then get the difference of the first number in the sorted array and the last number in the sorted array. And that's basically the same as here, the maximum number and the minimum number. Because we're sorting it, the largest is going to be at the front and the smallest is going to be at the end, or vice versa, depending on how you sorted it. So those are three ways that I thought of approaching this. Did anyone do anything different? And even if you didn't complete it, were you kind of thinking along different lines?
I was thinking the same way you were with max and min, but I didn't know about the spread operator. But that was a good one. Thank you.
Cool.
Yeah, so I went to go and I was gonna go and store the highest value, then go and get the minimum value, and then go and do the for each for every value, and then match them against my highest and lowest, and go through all of that. But because of the actual math operator, math.max and math.min, that takes out all of that stuff, and then makes it much simpler.
Oh, I see. So you were going to kind of do a hybrid of all of them.
Exactly. Get the max manually and the minimum manually.
Right. Okay. So that is, yeah, it's overkill certainly, but that sort of thing is really good practice. I think when you are finding yourself kind of doing algorithms just for, I hesitate to say fun, but just for kind of practice of problem solving, actually the best thing to do is to write it 3 different ways. And one of those ways could be really like just using for loops, not using these inbuilt methods, not using anything to make your life easier, just sort of storing variables and using for loops and if statements, like the simplest stuff you can have available. So it's actually really good practice to kind of over-engineer these solutions. So that's a good thing. Anyone else do anything different? Okay. So we're going to do one more, and then we will. I think we're doing one more, and then we will add tests into our project. We're going to add tests to those two, and then we're going to do 2 more, I think. Okay. Now we're going to do a pretty similar one. This time it's the maximum difference between adjacent elements. So where the previous one, we could just find the min and the max and get the difference. In this case, it is only, do we have an example? Let's use the same test array. Why does it do that? I don't like how max work a lot of the time. Paste without formatting. So our test array, in this case, the highest difference between adjacent numbers is going to be 5 and 28 is 23, 28 and 19, no, 19, 21, no, 21 and 4 is going to be 17, so no. So it's going to be 23, I think. So you only want to compare adjacent elements. So let's do that. You can copy the code, copy the code from the Slack message. Try not to copy any code from the previous set. There's 10 minutes on the clock this time, and off you go. And I would use a different file for this. So max adjacent. less than 5 minutes left. Okay, nearly done. There we go. Okay, so AJ posted something very early, but he was tripped up by the fact that the test array, actually the first pair is the pair with the greatest difference. So actually AJ's function that he posted is always going to return the difference of that first pair. So, does anyone want to talk about how they approached it? Did anyone complete it? Okay, no one completed it. I want to get some interaction from you. So I'm going to pick someone at random to tell me at least the direction they were going in. Theodora, what were you trying, and how far did you get?
My approach was similar to one of AJ.
Okay.
With math absolute, catching the array, something like that. I'm not sure.
Okay. Yeah. So, iterating over the array. Storing some kind of maximum difference maybe, and comparing them. Yeah.
Maximum difference with math.max, with maximum and temporary value.
Yeah. Yeah.
I'll post it right now.
Okay. Cool. Yeah.
But it's returning 23.
Okay. So let max equals -1. Okay. Yeah. Good. And then temp equals the difference. Yeah, okay. Max is then math.max, so the highest one. So you're setting max every time to either the current maximum or the temp value that would be higher if it is higher, and then you return max. So that seems good to me. And it should return 23 for the test data, but
it's returning 23
for the original test array.
Yes.
Oh, that's correct.
The one you posted on Slack.
Yeah, that's correct. Why do you think that's wrong?
Because the first time when I on the first task as well, I received 23. And
let's try calling test array. Yeah, it looks good to me. Yeah, 23, and then let's call it again with this different array. And there I get 978. Yeah, good, nice one. That's a good job. Yeah, so that is pretty similar to how I did it. I don't really think we need this this temp variable, but it kind of makes it readable. I probably would avoid calling it temp, and in fact you can have it inside that for loop. So you can simplify a little bit. So we've got temp equals the difference, and therefore I'd call that diff. That's, if you're going to use a shortened name like temp, the shortest and most abbreviated I think you're allowed in this situation is diff. It's the difference. And then you set the max to, you're basically setting max to either the current maximum or the difference, which is perfectly fine. Yeah, I like that. That's a good solution. I'm going to pick someone else as well. Mushtaq, do you want to post what you wrote, even if it's unfinished, even if it doesn't work?
It's on the paper. I wasn't writing anyway, so I was just thinking in the same way, probably to get the similar answer. So I declared a variable and I was iterating through your array, and that the unassigned variable had the multiplication of the first element and the second element, and say to that the variable, and getting the biggest one after multiplying everything and to get the biggest one. I don't know whether it would have worked.
After multiplying everything, that sounds unusual. But
no, I mean the multiplying two elements together and adding it to the variable, saving it, and multiplying up until it has the highest one into the variable that I declared.
Okay, I don't think we needed any multiplication, but all of that bit is fine, because you'll try it out and you'll realise that something's not quite right. But I think your first sentence was, I was writing it on paper, so I don't have the code. Was that correct?
Yeah.
Don't do that. That is, yeah. Why? Why are you doing that?
Because I don't have anything installed yet. See, I have a problem with my computer.
Okay. Okay, fair enough. I do know people who in the past have taken sort of notes and written pages of code in notebooks, and those people often don't learn quite as quickly as people who are just writing the code and trying it out. So
now the thing is, about 4 or 5 days my computer was hacked. And,
wow, okay.
I told Wassel I lost everything. Hardly today I got the logins from the iCloud and everything. So I'm without every software at the moment.
Okay.
Yeah.
Okay, well, fair enough. That's a legitimate reason to do it pen and paper. But for any of you that are tempted, it's just not worth the effort of writing down on pen and paper. But that's fair enough. You're off the hook. Okay, so yeah, and then the stuff that you kind of explained about multiplying, that doesn't sound correct. But the important thing is to be able to test it quickly and figure out that your algorithm is incorrect. That's the important bit, and to just kind of get something down. That is a very good question, a very good point. So Replit, there are others available. So Replit is one. JS Bin is another. Is a pretty nice lightweight one. Code. What's the one that I usually use? CodePen. Yeah, there's all sorts of online, not quite IDEs, but things to allow you to write code online. I have used it past, thanks Ajit. Yeah, good. That's a good suggestion. Okay, so the way I did it two different ways. The first way, to find out the maximum adjacent difference, I take the array that's passed to the function. Very similar to the previous one. I create a variable called current max diff. I realized in the previous one, highest diff is not the nicest name, so I changed it to current max diff. We iterate over our array, and that I think is not quite right. No, I think that should be all right. So if we are too far in the array that we don't have, we don't have another index to no, is that right? Is that, I think, okay, it's just -1. I'm going crazy. But then next number minus next number is going to be Oh yeah, that is correct. Okay, so if we're at the end of the array, if we're currently looking at 6, we aren't going to get a number after it. So let's just have an early return. For some reason I thought we would want to stop here, but obviously we do want to compare 4 and 6. So in this case, if we're at the last index in the array, there isn't an adjacent number after it. Then we get the next number, just again for a bit of neatness, rather than having array I plus 1 here and here, it just makes it a bit neater. Is the difference, and again we could neaten that up by saying diff is that, and then diff here and diff here. We work out the difference using the absolute value of number minus the next number. Is the difference that we're currently looking at greater than the maximum difference, the current maximum difference that we know of? If it is, let's overwrite it and set that variable to our new diff value, and then after all of our iterations we return the current max diff. So that gives me 23 in the test array and 978 in this second array. The second way I did it, I took my array of numbers and created an array of pairs of numbers, and those pairs are arrays. So let's just have a look at what pairs looks like. So here we have an array of arrays. This is known as a two-dimensional array. So our first element in this array is actually an array in itself. The second element of the array is an array. Each of these arrays have 2 elements. In other languages, this actually has a whole type of its own, or a kind of a class of its own, and it's called a tuple. And when we have 2 elements in an array, that's referred to as a tuple. So we have an array of tuples. We then map over that array of pairs of numbers. For every pair, we return the difference between that pair. So then we get an array of differences. So we take our array of pairs, map over each pair, and return the difference between that pair. So we get an array of the differences between each adjacent element. And then we can just call math.max, passing in all of those individual differences to math.max to find out the biggest difference between our adjacent pairs. I suppose we could have done something like that with the first one. We could have, in our first max diff, for every element in the array, iterate over the other array and like push all the differences into a differences array, and then returned math max with all those differences passed to it. Could have done something like that. So these were the 2 ways that I thought of. I'm sure there are others. Did anyone think of any other ways of doing it, even if you didn't really get very far? Hodan's gone, I've realised. Okay, no one's saying anything. So I'll assume you passed first time, or you went down the same route that I did, or you're just unwilling to share what you did, which is kind of not allowed, but also fine. Okay. Now we're going to talk about test-driven development, and we're going to add tests to these functions. TDD, or test-driven development, is incredibly common these days. I mean, it's not necessarily true, but pretty much any modern software company is going to be practicing test-driven development. So you kind of, everything, in an ideal world, every piece of code that you write can be tested, has tests written against that code, and all of your code will always pass the tests. One of the massive benefits is if you're working on fixing some bug and you do fix the bug and then you write a test to make sure that the bug is fixed, then you run all the tests in your project, and actually it turns out that you fixing that bug has broken some other test. And so these tests will run automatically before a project is deployed, and it just can't be deployed with failing tests. So that's really why companies use it. Of course, things can still go wrong, but there's this idea of coverage, and all of your code is covered by tests, and therefore nothing can go wrong. That's not true, but that's the idea. There's this idea of red-green refactor. So red is the first step, and that's because you actually are going to write the test first. So in our sort of practice that we were just doing, we had our test array, we were calling our maxdiff function with the test array, and we are expecting to get 23 back. We know the number that we should be getting back, so we're already doing kind of red-green refactor here. We're already starting off with something that's running our function, and we're expecting a value, but it throws an error or it doesn't give us the correct value. So we were already doing that, our test was failing. Then we wrote the code to perform the algorithm, the maxdiff algorithm, and once we had written the code that correctly finds the maxdiff, the test becomes green. So this is how you've been working on all of your exercises. You start off with failing tests, then you write the code to satisfy the tests, and then you refactor. So you then improve your code. It's really important to kind of separate this idea of just getting a bunch of green ticks and I'm done. You want to get your green ticks, you want to get everything to pass, but also you want it to be good, well-written, readable, reusable code. So the first priority is passing the tests, and then the second priority is refactoring so that, of course, the tests still pass and it's actually nicer code to use. So there are all sorts of different types. This that we're going to do now is unit testing. It's basically referring to the smallest parts of a project. In this case, it's just our single functions. These are all units, and we write tests that just test our units. Then we can write tests to test how our different units fit together, and that is known as integration testing, and how users use your app and all of those units then fit together, and the whole process, that's known as end-to-end testing. We are going to look at unit tests. They're kind of the simplest to write and what you generally write the most. End-to-end and integration testing is kind of much more annoying. I think it's much less common that people will write integration or end-to-end tests as much as unit tests. And last point here, Jest. That is the JavaScript testing framework that is incredibly popular. There are others, but generally any kind of testing library that you use is actually using Jest behind the scenes. So that's what we're going to do. I hope you will be familiar with the test syntax by now, because I hope you have looked at the exercise tests in your exercise repo. It's a good skill to be able to read them, and luckily this is Jest, but all test frameworks are written in this way. It kind of reads in a very semantic, a very easy to understand English way. So this is a test for something, and I expect something to be this value. That is how it should read. Sometimes tests could be written by people who are sort of slightly less technical. They code, it's still writing code, but they could be at least defined by a product owner. A product owner could write, I expect the user to be redirected to the dashboard after they log in successfully. And that is what they will write to you or to a developer. And that sentence can very easily be translated into a test. So that's kind of one reason why they are written in such a way. Okay, so we're now going to run a bunch of commands. npm init y. So npm init initializes a new project with a package JSON. There's a whole bunch of like default options. So if I just run npm init, oh yeah, okay. This utility will walk you through creating a package JSON file, blah, 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 blah. Package name, it kind of guesses a package name that you might want, which is just the name of the directory. So that's close enough. Yes. Version, yeah, yes. Description, don't really care. So yes. Entry point, Mac, yeah, whatever, that'll do. So I'm just saying yes to everything, and it's created a package JSON for me to add all my dependencies and stuff. npm init -y just does all of that yesing for me. So it just says yes, it accepts all of the defaults. So that's why for now we're doing npm init -y. I now want to install Jest. We can create index.test.js. Now this actually, so this would work, but the naming convention for test files is pretty much that there is test in the name, and quite often you will create test files for equivalent non-test files. So we're not going to have index.test, we're going to have maxdiff.test.js. VS Code knows this is a pattern that is very common, so it's even highlighting the sort of type of file in a different color. Our standard JS file, once that has been installed, we, oh dear, what, that's not going well at all. once that's been installed, we can update, in our package.json. So if we run npm test now, it just says error, no test specified, because that's the default behavior here. We can just run jest to run jest, and it will look for all of our test files. So now let's run npm test. It actually runs jest, which then finds our test file. So it's now running maxdiff.test.js. There's nothing in there, so it's going to say your test suite must contain at least one test. So that's not quite everything. Module.exports. I think we talked about module exports in the past. This is how we take functions and variables from one file and export them from that file so that we can access them in a different file. That's essentially what's going on. So module.exports, we want the thing that gets exported just to be maxdiff. Don't worry about that too much. So now I've got a very itchy nose. Sorry, maybe you wouldn't have noticed if I hadn't have said it, but I feel self-conscious about itching my nose. Okay, and my computer's being ridiculously slow, so even moving that around is not good. Okay, so rather than moving on to factorial, which we're going to do later, we're now going to write tests for maxdiff. So first, we want to require, so this is Node's way of loading up a file and giving us access to whatever has been exported from that file. So in this case, we get maxdiff. So we get access to that function. We then want to write a test to, the annoying thing is, because the way we run jest is just by basically running jest in the console. We actually don't import or require jest inside this file, and therefore VS Code doesn't actually know that we have access to all of the jest functionality. So it's slightly annoying. But we start with the function test. Maxdiff returns 23 when passed these numbers. So that first argument is the description. The second argument is the function that is actually going to perform the test. So it's a callback function, and we are going to expect maxdiff, pass in the array to be 23. So let's run it again, npm test. It runs jest. Jest sees our .test.js file and it runs it. 24? Oh, right, okay. It is 24. 24. I was wrong the whole time. 5 and 28. 4, of course, there's a 4 and 28. So we get 24 maxdiff to be to equal. No, I've done that wrong. Okay, it's slightly annoying with all the brackets. So actually, let's say result equals calling maxdiff and then expect result to be 24. So let's try that. I don't know why it's so slow. Okay, great. We now have passed. Yeah, we get all our console logs that are happening inside that other file, but that's fine. We now have that passing. We can do the same thing for this different array. And here we want to get 100. Okay, great. So you always want to write multiple different tests. In fact, in this case, I probably would have only one test for max diff returns the max diff, and I would have several checks. So max diff returns the max diff, and result to be 24, and then next result to be 100, and then this one, max diff, works fine when encountering something other than a number. So max diff null. Let's see what we get. Okay, it still worked, I guess, because math abs null, that's, yeah, because JavaScript is crazy. But here we have 2 tests inside this one test. So because we're all checking, or kind of all of those tests are checking for the same functionality, so really you can have multiple expectations inside one test. But here it's different functionality. Actually, that's probably gonna what's gonna cause this to break? I think maybe an object. No, that's still passing. No, that's still passing. It's too good. What I've done is too good. Let's test some stuff out. I think it's because I'm using math.abs. So let's say 100 or 10, whatever, minus an object, minus that, so minus some kind of string. Also, that gives us nan, but math.abs, what we're doing is like 1, and then not a number. Oh no, sorry. 1 minus nan, which gives us nan, and then we're doing something like math max 1 nan. Oh. So not a number is greater than 1. How on earth does that work? It's also less than 1. What? Okay, whatever. I mean, I guess the test is fine and is passing. I suppose a better test might be to pass something that actually isn't an object, or isn't an array, sorry. So if we pass an object, fingers crossed, it's going to break. There we go. Because array for each is not a function, because that's not an array. So we've got 2 tests for max diff. What time is it? Okay, let's let's do factorial for 10 minutes, and then I will show you how I do it, and then write the tests for factorial, and then if we have time we'll look at palindromes. Okay, so the factorial of a non-negative number is the product of all positive integers less than or equal to that integer. So 5 factorial is 5 multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1, not multiplied by 0, and therefore 5 factorial is 120. The factorial value of 0 is actually 1, which doesn't make any sense, but there's probably a very fun maths video you can watch about why that is the case. In fact, I'm probably going to watch that video this evening because I'm sad and I'm curious. So again, so write your tests first. Okay, 15 minutes. Okay, this one says 15 minutes on the clock, write your test first. I think I've gone a little bit slow, so actually don't write. By this I don't mean jest tests. I don't think there's enough time to do that, so I'm going to post these 3. I mean, if you want to, please do go ahead. I'm going to post those 3. Those 3 are your tests, so you can just log out factorial 5, 0 and 10 just to make sure that you're getting the right values. But we're going to have 10 minutes on the clock, and then I will write the tests using jest a bit later. No, stop, start. Good. Okay, 10 seconds left, and I'll stop there. So Daniel posted a test that I think looks good, that should work. Does that mean that you have, were you writing the test first, or had you already written the function, Dan? He doesn't want to answer me. I just wrote the function. Okay, so you wrote the function and then you just wanted to sort of try out writing a test. Maybe, I think that's what I gather from that. I'm going to pick on people because I sort of forgot about doing that last time, I think. So we'll start with you, Daniel. Paste what you've written, or kind of read it out and explain your thought process.
For each one, right? Or
What do you mean for each one? Just
like factorial 5, factorial 0, even though they all kind of basically follow the same principle.
Oh, for the tests.
Yeah.
Okay. So, have you written the function called factorial?
No, because I thought factorial was the function.
Aha. So factorial is the function that we want to be testing, but we have to write the function called factorial as well. So maybe that was me not being clear. But yeah, so we want to write the function. Did everyone do that? Did I mess up and explain it incorrectly? Because Mushtaq also saying, I guess before test we should have a function. Okay, Theodora, we have one. Okay, so we've got a function called factorial and it takes a number. We're storing a result variable that's initially set to that whatever the number is. If it is 0, or in fact 1, I like that, then we just return 1. We don't do any kind of calculations or any loops or anything like that. We know, because it's a rule of maths, 0 factorial and 1 factorial both return 1. I forgot about 1, so good job. Then if it is greater than 1, then we iterate using a while loop while our number is greater than 1. We keep reducing our number and we multiply our result by that number. So yeah, good, that looks really good. That's pretty much how I did it, although better because you actually had number is 1. So if number is 0 or number is 1, then return 1. We set up our total and our multiplier. So Theodora, in your example, you're decrementing num, the number that you get through as the argument in the function, which is actually fine. Where with an array, arrays are passed by reference. And I'm sure we've talked about this in the past, but it's quite a kind of difficult topic to get your head around. Arrays are passed by reference. So we have an array that's defined up here, and we pass it to this function, this function, and this function. And it's actually all the exact same array. So if this function changes this array, when the second function gets it, it's going to have changed and it's going to receive a slightly different version of the array. Whereas with numbers are passed by value. So in fact, if we have a variable that is set to the number 4, and we pass 4 to this first function, and it does what you're doing here, and it says 4, or number, minus, 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 it kind of keeps going until it's at 1. Actually, it's not changing the original value. So the next function is going to get the number 4, and then the next function is also going to get the number 4. So although what you've done is fine, I like to kind of get into the habit of avoiding changing the values that are being passed through. So here I'm creating a kind of multiplier variable that's initially set to number -1, and then I'm subtracting, I'm multiplying the total by the multiplier, and then I'm subtracting from the multiplier variable rather than the number variable. It's kind of unnecessary, but just doing that sort of thing gets you in the habit of not accidentally changing the reference values that are being passed through to your functions. So I did it two different ways. One exactly the same as Theodora, and then this way, pretty weird. I used an array, so create an empty array, kind of create a for loop, could have been a while loop, but just create a loop to count down from that number all the way to 1, push in the kind of counter, push in all of those numbers to our numbers array. There's other ways to do this, it's a little bit weird. And then I used reduce to take our array of numbers and reduce it down to just one number, where it's always the total multiplied by the current number that we're looking at. It's pretty weird. I wouldn't necessarily recommend doing it this way, but again, just doing it multiple ways is really good practice. So I really encourage you to do that. So now let's write the tests. So factorial.test.js. Now we want to export. Module export is our factorial function. We save it. We import factorial, or we acquire factorial from factorial, and then we write our tests. So factorial gives the factorial of the number. So we could do something slightly different with this one. We're going to have okay, no, that's not quite right. Numbers to test. We're going to store that as an array up here, and then we're going to iterate numbers to test for each number to test. We can actually call expect number to test, expect factorial number to test. Factorial number to test to be, oh right, yeah, numbers to test, number outcome, so 120, number 0 outcome 1, number 10 outcome, what was it, 1 3 3 6 3 6 2. Okay, so we now have an array of objects. So number to test, test data, let's call that. Now test data dot number. We expect the result of calling factorial, passing in the number each time, to be the test data dot outcome. So let's run that. So test or jest is seeing that we now have two files with test in the name, and we are passing. Why? What's going on? Why isn't it describing the test to me? It takes an awfully long time as well. Factorial. Oh, I don't know. Max diff. I reckon it's because there's two different files here. I don't really understand why it's not printing out the test description, but never mind. We've passed everything. I think you can pass an extra flag to jest to print out everything, even if it passes. I think the important thing really is that when it fails, so let's change this expected outcome to be something that's actually incorrect. Now we should get a bit more of a description because that is going to fail. Yeah, so factorial, give the factorial of the number, expected 121, received 120. Actually, that's wrong. So we're all good. So you can write tests that are a little bit more dynamic if we now want to just add another function to test it, another number to test. We can just add to the original array. We don't have to test manually. So that makes it a little bit nicer. Okay, Mushtaq says to be or to equal, to be or not to be, which actually you could write in a test file. To be and to equal is a good question. So when you are comparing values in JavaScript, you can, trying to think of an example. I imagine their documentation gives a good example, but to be might be used if you want to actually return from a function, you want to return the exact object that you're looking for. Is the player returned from the find player function, is that exactly this player object? Whereas equal, it's kind of like, does it have all of the same key value pairs as my player object? So is it the exact same object, or is it the same as my object? So they're quite difficult. Let me see, just to be versus to equal. I'm sure there's a page. Of course there's loads of Stack Overflow and things, but I think expect not to be used to be to compare primitive values or to check referential identity of object instances. Yeah, exactly. So to be don't use to be with floating point numbers. To be close to. Okay, right. It doesn't mean to equal. So here we're using it for primitive values, which are strings, numbers, booleans, that it? I can't remember. Whereas to equal will be used to equal to say, is it the same, like pretty much the same as. So here it looks at the properties of objects. So are the key value pairs the same? It's a relatively small issue. If you're writing a test and you're certain it should be passing and you're using either to be or to equal, it's worth trying the other one to see if that's the cause. But that's something that it'll take quite a long time to kind of really understand the difference between reference and value. Okay, and that's 8. So palindrome, I want you to do this now. Paste your results in the Slack channel and write tests as well. So those are 2 possible tests. Of course, there are loads. So write the function is palindrome. Write the tests for it. Writing tests is really good practice. It's something that you almost certainly will be doing from very early on in your careers. So do write the tests. Do write the is palindrome function. And for those that don't know, a palindrome is have I said what it is? No. A palindrome is a string that is the same forwards as it is backwards. We're going to do it without any punctuation or white space or anything like that. So some other tests that you might want to do is race.car, for example. That, if we strip out all of the punctuation and the white space, RACECAR, it is the same forwards and backwards. So double check that it can work with punctuation, and that's your post